So today we are going to discuss about colligative properties. So generally colligative properties of the solutions are four types. So then first one is what is relative lowering vapor pressure. So that is RLVP, relative lowering vapor pressure. Already this concept is completed in last week. So then second colligative property is elevation in boiling point. But the second one is elevation in boiling point. Elevation in boiling point. So now third colligative property is depression in freezing point. Depression in freezing point. Depression in freezing point. So now fourth colligative property is osmotic pressure. So it is the osmotic pressure. So generally osmotic pressure is denoted with pi. So then elevation in boiling point, it is denoted with delta TB. So it is the delta TB. Depression in freezing point is the delta TF. It is the elevation in boiling point. It is the depression in freezing point delta TF. So then osmotic pressure is pi. So then first one is completed. So now second one is elevation in boiling point. Elevation in boiling point. So now, so elevation in boiling point. For example, so let us consider a vessel. Let us consider a vessel. So now a pure solvent is taken in the vessel. So now it is the pure solvent is taken in the vessel. So it is the solvent. So it is a solvent. So for example, water is the best solvent or universal solvent. So now vapor pressure of the solvent is more. Generally solvent is more vaporizes. So then for example, solvent vapor pressure is denoted with vapor pressure of solvent is denoted with, for example, X. What is it? X. Now addition of non-volatile solute. Addition of non-volatile solute. Non-volatile solute to the solvent. So now non-volatile solute is added to the solvent. So then a solution is obtained. So now it is the solution is obtained. Now the vapor pressure of the solution is Y. Say Y. What is vapor pressure of the solution is Y. So now in this X and Y, X is greater than Y. What is X is greater than Y? It means the vapor pressure of the pure solvent is greater than vapor pressure of the solution. Why solution vapor pressure is decreases? So then addition of non-volatile solute to the solvent. This non-volatile solute decreases the vapor pressure of the solvent. Vapor pressure of the solvent. So vapor pressure of the solution, it is less than vapor pressure of the solvent. For example, if the vapor pressure of the solution becomes to vapor pressure of the solvent, so it means X equal to Y. It is possible when so now the solution heated at high temperature. If the solution both are equal, when if solution heated at a high temperature. What is a high temperature? So high temperature means high boiling point. What is a high boiling point? So now at high temperature, the vapor pressure of the solution becomes to vapor pressure of the solvent, or the vapor pressure of the solution and the vapor pressure of the solvent becomes to atmospheric pressure. What is atmospheric pressure? This pressure is known as elevation in boiling point. What is elevation in boiling point? It means, so then vapor pressure of the solvent is greater than vapor pressure of the solution, but with respect to boiling point, so this order with respect to vapor pressure, but with respect to boiling point of the solution is greater than boiling point of the solvent. So now the difference between boiling point of the solution and the boiling point of the solvent is known as elevation in boiling point. What is elevation in boiling point? For example, Y is the boiling point of the solution. So boiling point of the solution is denoted with TB. What is the boiling point of solution is denoted with TB. Boiling point of the solvent is denoted with TB naught. What is TB naught? Now the difference between TB and TB naught is known as elevation in boiling point. What is elevation in boiling point? Simply it is denoted with mathematically. So now elevation in boiling point delta TB. What is delta TB equal to TB minus TB naught. What is TB minus TB naught? So wherein delta TB is the elevation in boiling point. It is the elevation in boiling point. So now what is TB? TB is the boiling point of solution. It is the boiling point of solution. What is delta TB naught? So TB is the boiling point of solution. TB naught is the boiling point of solvent. What is boiling point of solvent? So now the boiling point differences between solution and solvent is known as elevation in boiling point. Why the boiling point of the solution is increases? Why the boiling point of the solvent increases? Because the addition of the non-volatile solute to the solvent. So then non-volatile solute decreases the vapor pressure of the pure solvent. What is vapor pressure of the pure solvent? It is elevation in boiling point. So it is explained with respect to graph. Okay, now the graph drawn between vapor pressure and temperatures. What is a graph drawn between vapor pressure? And temperature. So for example, vapor pressure is taken on y-axis. So then temperatures is taken on x-axis. So now it is the x-axis. What is the x-axis? So these are the temperatures. Temperature means simply boiling point. So it is the temperature. So now vapor pressures are taken on the y-axis. So then it is the y-axis. What is the y-axis? So simply, if the boiling point increases, generally what happens? Vapor pressure also increases. What happens to vapor pressure also increases. For example, solvent boiling point is less. While solvent boiling point is less, its vapor pressure is more. For example, this value is what is delta or what is TB. What is it? Is the TB naught. What is TB naught? Boiling point of the solvent. So boiling point of the solvent. So then it is the vapor pressure of the solvent. What is the vapor pressure of the solvent? So generally vapor pressure of the solvent is denoted with what is? It is the P naught. What is a P naught? Vapor pressure of the solution is PS. For example, it is TB. what is it? TB. So from left to right, boiling point what happens? Increases. If the boiling point of the solution increases, its vapor pressure what happens? Decreases. So solution with more boiling point, less vapor pressure. Solvent with low boiling point, more vapor pressure. So then what is it is the vapor pressure of the solution. So then it is the PS. What is PS? So PS is the vapor pressure of the solution. P naught is the vapor pressure of solvent. TB naught is the boiling point of solvent. TB is the boiling point of the solution. So now in this graph, what is in this graph? So now it is, what is, for example, it is. So then it is A and it is B. What is A and B? For example, it is C and it is D. What is C? It is D. So the curve AB gives the information between boiling point of the solvent and vapor pressure. What is the boiling point of the solvent and vapor pressure? So the curve, what is the curve? The curve of AC, so the curve of AB, it gives the vapor pressure. What is vapor pressure? And also vapor pressure, and also what is boiling point of solvent. What is boiling point of solvent? But the curve CD is gives the information about vapor pressure, and the boiling point of the solution. What is the boiling point of the solution? So it is the graph between temperature. Okay, graph between temperature and vapor pressure. So it means pure solvent vapor pressure more, boiling point is less. Solution vapor pressure is less, but its boiling point is more. Its boiling point is more. So now next one is, so generally delta TB. What is delta TB? It is directly proportional to delta P. It is directly proportional to delta P. So what is delta P? Delta P is the lowering vapor pressure. What is lowering vapor pressure? So lowering vapor pressure is equal to P naught minus what is PS according to Raoult's law. According to Raoult's law. So then delta TB is directly proportional to delta P. What is delta P? So generally, according to Raoult's law, delta P, okay, delta P is directly proportional to X solute. What is delta P is directly proportional to X solute. So simply, so then delta TB is directly proportional to X solute. What is X solute? So X means mole fraction. So wherein X is the mole fraction.